just like better to learn math in this way of like explore, play with, don't be afraid to get things wrong. So our lesson today was essentially like going through and just teaching you the stuff that we could figure out from doing the Desmos activity. So I have sent your new math notes to the copy center, but I kind of like that they're not back yet because now I put them in here and I'm going to upload all our practice work here today because I was just going through and editing, making sure I liked all the copies before I made copies. But if you really want to see the math notes, you can, and I'll upload the PDF here like today. This is just the Google Doc because while I was still working on it, I figured then you could go look at it. But I'm not asking you to go look at that right now because through the Desmos activity, like selecting all the angles that you think are congruent or selecting all the vertical angles, like you're gonna learn what you're supposed to learn from the lesson today. So please read through the directions. Do as it says, and if it's like a mark all of them, slow yourself down and actually think, are there any others that are equal? Like, all because you marked one doesn't mean that's all of them, right? Is it 7?
Sure, it can be 7.
If it's 0.7, I do. If it's not, I don't.
Yes,
So come over here and we can try it. I mean, if it's too small, it's just going to fall out of your pencil.
No, it's fine.
If it's too big, it just won't work.
It's fine.
So take your eraser off or whatever. This might be 0.5 or
It's a 0.2.
it's 0.5.
Oh, no,
This
you're right,
won't
it's
work.
0.5. No, can I have one?
No, it won't work.
Oh my god.
Hey, hold on. I know that you can keep track of a pencil because you kept your whatever pencil for a week.
Oh my god, I almost get my own color. Oh, a sleigh.
No, that's what Santa drives. These are pencils. Hey, for real, we're like running out of pencils as a school, so we need you guys to try to keep track of your pencils. And I do have lead. Like, if you're using a mechanical pencil, I got a bag full of lead. Like, a kid, I don't know why, but a student had a ton of lead. It's all 0.7. But at the end of the year, when we clean out lockers, like, lots of you guys are going to pull stuff out of your locker and go, I don't want this. Do you want this? And you're just going to, like, offer it to your friends and teachers and what. So that's how I ended up with a bag full of lead. It's also not actually lead for anyone who cares, any of our sciencey-minded people. Amir, are you still getting in? Maddie, you still getting in, even though you don't need that pencil to do your Desmos? Will, you getting in?
I like to hold it.
Ahmad, you getting logged in? Yeah. Okay.
Thank you, sir.
Yes, Alex.
I'm pretty sure lead is made of graphite, which is
It is
technically
graphite.
pure carbon in crystal form.
I didn't know that much, but I did know it was graphite. So you took it further than what I knew. I have a bone to pick with you guys. Because you are leaving art on surfaces I have to erase. Please quit drawing on my tables. I don't even care so much as like, the kid drew on my table. Like, whatever, you're kids, you're gonna draw. I mean, people draw. A lot of adults sit around drawing. But when I have to then Clorox wipe it and make it disappear forever, a little bit of my heart breaks because I'm not as good of an artist as you guys. So if you're gonna draw on paper. I don't care if you draw, but quit drawing on my tables. Now, where I really would care if you drew on the table is Sophia's table. If I catch anyone drawing on that or like scratching into it or like defacing it in any way, you are going to write a letter of apology to Sophia that I think is comparable with the effort she put into the table. It will be a long letter. You will have to be very detailed about how apologetic you are. Or we could avoid all of that by just respecting the art and not messing with that table. The rest of my tables, I don't really care about. I mean, I kind of like the IKEA table. It's sort of nice. But the rest of, do whatever. But, like, please don't. Also, because that one's a little harder to clean because it's polyurethane as opposed to just, like, the fake plasticky tops. So, yeah, let's try to respect Sophia's art, please. What'd you say, Ahmad?
In that case, I have a tendency to draw without actually thinking about it. So I'm
Just
definitely
put
not
paper
sitting at that
down.
table.
Just put paper down. Ada, why'd you skip the first one? Go back to the first slide. Yeah, go back to the first slide. Yeah, we're running out of pencils. I'm sorry, guys. I have none.
I apologize for this post for proper definition.
Congruent. Who can help out Alex? What does congruent mean? Or you could copy paste and Google it if you wanted to. Owen?
Looks like the same.
The same.
Oh, okay.
It's mathematical's fancy way of saying the same. I know we could say equal, but with geometry, we normally use the word congruent.
I used to think it meant it had to be exactly a 90-degree angle from it.
That is perpendicular.
Oh.
Yeah, that's perpendicular. So congruent just means same size.
Now I remember it.
Yep, same size. So you're looking for angles of the same size. So this example should maybe work for you guys, at least like, my drive home. Guys, train tracks always have to be parallel or the train will fall off of it. I don't know if you guys know how train wheels work, but there's a flat part and like a lip, and if the tracks got too big, the train would just literally sink into the middle of the tracks because it just rides along. It doesn't grip both sides of the track. It only grips one side of the track. So if you imagine train tracks with then a road going across it, we know that like certain parts of this are going to be the same angle, other parts of it are going to be different angles. And if you look at your 911 homework on the back of it, where it reminds us of our definitions of supplementary and complementary, we probably have one of those special relationships happening here also. But go ahead and keep going. I need to resist the temptation to teach because I say I like letting you guys discover the math, but then I want to teach. Akma?
Does the orientation matter if it's congruent?
You tell me. Does the direction and angle points change the size of the angle?
No.
No.
I thought you meant like the same, like exactly the same.
No. We're talking same size, right? Like same degrees.
Alright.
Yeah, they both need to have a bachelor's or both have a master's, same degrees. That might be the worst joke I've made and nobody even paid attention. Ada, you're flying through this. Go back to slide 3. Guys, on slide 3, it's all. We need all angles that are congruent to angle A. There's more than one. There's more than two. Some of you disagree with each other. So, now only 2 of us disagree. So, mine is only, this person must have been the first one if theirs was the only one you could see. All the angles are the same angles. I don't know if I agree with all the angles are the same angles. Mostly yes, if 2 parallel lines, you have another. So guys, I'm curious real quick to look at what you guys had here. Ooh, lots of dots over here on like the top left of this intersection. A couple over here on the bottom right. I think that's what everyone probably saw once everyone made it through. It's interesting that more of us picked kind of the left side of the blue line. And a couple of us picked it down here. Because you only had one dot to drag in this one. It's like we don't need to actually talk about this. It's just interesting. Keep going. Keep going. Oh, now only one of us disagree. It's scary when we're the only one, right? Sometimes it means we're wrong. Sometimes it means we're the only one willing to disagree. Beatrix, can you pop back to slide 3? Ahmad, could you also pop back to slide 3? That one's tricky because we got to mark all of them. And I don't mean mark every single angle. I mean mark all that are equal to the first one given us. I know, but I'm pretty sure angle A feels obtuse. Right? Doesn't that feel like it's not an angle? So if A is obtuse, and we look at this angle on the right side, and we know that the blue line is a straight line, and that angle is obtuse, what would we know about this angle here? It'd have to be acute. Can an obtuse angle be equal to an acute angle? No. Just do your best. Do your best. This is the point of Desmos. Just try it. Just put in some effort. It's okay if it's not perfect. You're not like presenting to a room of doctors. You're just in a room of middle schoolers, right? Just do your best. You guys got to quit thinking everything is so high stakes. Just have fun, learn a little bit. It's the point of life. Did you guys hear about Richard Simmons making people freak out? First off, you probably don't know who Richard Simmons is. So Richard Simmons is a fitness instructor, but he got famous with how he did it was very come on guys, let's go. We got he was very animated. And he posted on Twitter or something, and he said, I regret to tell everyone, I'm dying. We're all dying. Every day, we're a day closer to death. You need to enjoy your life and be healthy. But everyone freaked out. They're like, you're dying? And he was like, I didn't mean I'm actually. He had to, make a whole public thing about, guys, I'm not dying. I was trying to motivate people to be healthy. Because that's his whole thing. It's be healthy. So it was very funny about, hey, words. Words are important. Ahmad, let's go back to slide 3 real quick and check that out together. Sorry. So, it feels like A is probably an obtuse angle, right? And if the blue line is a straight line, we know we've got 180 degrees between the two of them, so the one beside A is probably acute, right? So I agree that these would be equal because this one vertical to it would be the same size. If we kind of imagine sliding the red line on top of the other red line, and these angles are really close, so I can't quite tell where you put your dots. So scooch them away a little bit. So if we imagine sliding this red line over onto this red line, where would A be if we slid the red line here? So let's drag one of these dots there. So then, again, any angle vertical to where A would be equal to A. But then, if this is obtuse, and we said that this would then be acute, can these be equal to each other? No. So I think you just had those kind of flip-flopped on this other intersection. So if you imagine putting the red lines on top of each other, that could help. Yeah. Claire, are you cheating? No, I'm just joking. You're totally fine to look things up. Use your resources. Another way to define that, Claire, since you can also Google with real people, is a supplementary pair. Is another way to say a linear pair is supplementary. All right, so this is tough to put into words. Oh, sorry, not this one. Sorry, the person who asked me about the other one. This one's not as tough to put into words, but describe 2 to 3 things that we notice about how the angles relate to each other. The congruent angles are diagonal to each other. Yes, but more technically, the math word we use is vertical, right? This is not correct. So I think we just need to remember our vocab. Perpendicular means they gotta be at 90 degrees. Now you might just be like misseeing what, but these are not 90. A is obtuse, right? A is an obtuse angle. So be careful. If you're Richard Tapia, which every time I see his name, it just makes me think of tilapia, like the fish. But yeah, if you're Richard Tapia, be careful. Perpendicular means they got to be 90. If you flipped both around, you'd still end up getting the same angle. Ooh. So like if you imagine reflecting onto the other one or rotating around or sliding over, like, yeah, there's a lot of ways that you can imagine. They both have a curved angle mark. They're both next to each other on the parallel lines. And they both have the same amount on each side. They're facing the same 2 directions for the angles. The angle is directly opposite of the angle is congruent. Yeah, diagonal, the better word is vertical. All angles vertical to each other. Now be careful, all of them are not vertical to each other. We have vertical pairs, but be careful, it's not all of them. 2 different sets. I love that. We identified like, all right, I kind of have like an A set, and I kind of have like a B set. All right, keep working. Ooh. Sorry, I kept scrolling as I moved over. All the angles that are congruent and the same no matter the side to the angles make 360 degrees. Because if we come in here and we actually look at it, yeah, if I add up 4 of these, I make 360. So if A is equal to A and B is equal to B, like they got to add up to 360. They're all on top of angle A is obtuse, B is acute. They're vertical to each other from the bottom. If that makes sense.
Just like the whole back of the paper, the examples from class.
No, it's just that very bottom part.
Okay.
Now, we could have a fun time and do number 13 together if we wanted. Here, let's take a pause and see if we understood the vertical line test. Now, I'm going to immediately unpause you so I don't forget. So, like, don't get mad at me. But look at 911. Yeah, that camera's not on. Now it should be on. On the back, 13 asked us to identify functions or not functions, and we can do this by utilizing the vertical line test, which I can visualize by literally using a ruler as my vertical line. If at any point my vertical line hits my graph twice, it fails and is not a function. So A, is A a function? Yup. Since we're already looking at it, what about D, the one right below it? D's chill. D's funky, and actually, if you'd like to label it, this is what x cubed looks like. Vertical line. Do I ever hit more than once at one time? No. You are slashing your sword in random air. Take time to strike strategically. Now I gotta share it with the class. I made, can I?
Oh my gosh. Go ahead.
If you say no, I won't.
Go ahead.
So I made an analogy, I think analogy might be metaphor, to Maddie this morning. I'm bad at that game because I'm not an ELA teacher. That when she is trying to get the right answer for a math problem, it's like there's like a knight or somebody coming at her. She's in a sword fight, and instead of like lining up and like taking the time, she's just like, "Ah!" Give yourself time to be strategic and think. Do not just slash randomly in the air.
At least it's a way of it.
So this still passes. Even though it's a funky graph, it still passes. What about B? We fail. And if you'd like to show why it fails, which you should, because then you'll learn it better, draw a vertical line and show that it hits not just once, not even just twice, but it even hits 3 times. This fails terribly. What about E, since we're already kind of looking at that one? Yeah, definitely not a function either. What about C? Ooh. This is like that question from your test that we'll probably spend some more time on this week. Can one input have 2 different outputs? No, and I even tried to make this even more dramatic by changing this to red up here. Every input can only have one output. So if your X goes to 2 different locations, that's like you put a chicken into the machine and you got out fish sticks and beef. Like, what? That doesn't make any sense. So this is not a function. What about F? Yeah, because I only have 3 points. None of them are lined up on each other, right? None of them line up vertically with each other. So yeah, this one passes also. All right, let's keep working on our Desmos, please. By the way, question 912 is very much like one of those, a train leaves the station going, yada, but it's not that difficult because you don't have to worry about how fast they're going. I should really stop talking because I feel like I'm making it more confusing. 912 is just one of those fun problems. And yes, I know my definition of fun might be a little different than some people. Then again, I find sleeving the cards of a card game, I find that fun. Well, I'm weird.
That's not weird. That's like taking,
It's like satisfying.
for real, that's like shoving like your finger in like the green stuff at like the gardener's section. Like the gardener area in like Home Depot or like Michael's, like the green block and like it'll crush on the side.
You're damaging the product.
Well, I do it only do it to like one, and it's only
Home
like,
Depot, her name is Mad.
But like, yeah. I should get a hobby.
You're right. I know. Look, I know what you're talking about because that's what we used to have at church to put all the flowers in, right? The fake flowers.
Yeah, you better be careful. Today's assignment number is 911.
I do. I need another hobby. I need it.
I mean, I pretty much make going to Home Depot a hobby, but I don't destroy the product while I'm there. Vertical angles. Sorry, not vertical. We're already past that. Linear pair. So a linear pair, also known as supplementary, but Supplementary angles don't have to be connected. Supplementary angles just add up to 180. If they're supplementary and adjacent, you might want to write this down. What makes these also adjacent?
Because they equal 180 and they complete each other. Oh, sorry, I was looking at supplementary.
Yeah, EFG says to GFH, you complete me. So what makes them adjacent is the shared side. So these are also adjacent, if you want to write that on your paper. Up to you, because the shared side. And that reminder is in your math notes. But I didn't want to show you math notes yet, because this activity would kind of be ruined by going ahead and having math notes. So, what do we know about a linear pair if the two angles add up to make 180? Well, they're always supplementary, but that's not what this is asking. Could linear pair angles be equal to each other?
Yeah.
Sure, what if I rotate this blue line to make each of these angles 90? Because if they're both 90, they're supplementary and they're congruent. So this would be sometimes, although most of you have moved past this. All right, keep going. Ooh, now we get into the fun. Slide 9 is where the fun really starts. And if you have moved past slide 9, there's a 50% chance you marked it wrong. Okay, not 50, probably about 30% chance. What I'm saying is a couple of you have mistakes on slide 9. Same side interior. Another pair of same side interior angles. You could, if you want to incorporate your Desmos into helping you with your homework, I don't know how much this really is going to help you. You could make little notes here about hey, this is what we call the interior of our parallel lines, and out here is what we call the exterior. And relating this little image to our Desmos, what would we call 1 and 3? No, adjacent, they have to share a side. And it can't be this side that they're sharing so 1 and 3, they're interior. And what, Ahmad? Yeah, these are same side interior because they're on the same side and they're interior. Now, what happens if they're same side, but so check this out. My orange, angle 3, actually, no, I can go ahead and do this. Angle 1 and angle 4, are they same side? Are they interior? No, only 1 is interior. They'd be corresponding, because if you imagine putting the line on top of the other line, they're the same place, right? Bottom, left. So 1 and 4 would be corresponding with each other. Now, if you are just, craving that math, and you really can't resist checking out the math notes, everything we've covered today is in these math notes. Corresponding angles, alternate interior. Did I put that in there twice? Oh no, Mr. Hudson. No, it's two different sections about corresponding. So no, it's not identical. Same side interior, it just had to drop to a new page. Exterior and remote angles, this stuff we'll get into tomorrow. in 9 and make sure you didn't misread that. Amir, actually, same message to you. Make sure you didn't misread. Just remember, not just thinking about the picture you're looking at, but could they ever? So we're thinking about generally speaking, could they ever? And Laurel, be careful. It wants same side interior on slide 9. Yeah, you want to show same side interior, like the green angles they showed you. My advice would be keep working through this Desmos, like outside of class or potentially tomorrow. Like I'll try to carve out some more time because it looks like most of us need more time for the Desmos. Actually, the only ones of us that have made it out to slide 15, if you've left the activity, your slide 15 is not correct, apparently. Owen, you didn't mark all that applied in slide 15. If you want to challenge yourself to actually like get it all right, slide 15, there are more correct answers. So would you forget to mark? Guys, what angle type or like what special angle pair is always gonna be equal no matter what? Mick? Vertical. Vertical angles are always equal no matter what. Because you've got two lines hinged in the middle, or like connected in the middle. Whatever happens to the top happens to the bottom. Whatever happens to the right happens to the left. Your vertical angles are always equal. Right? To give a different visual. So, if you have two lines, right? We said the definition of vertical, some of you called it diagonal to start, some of you called it like opposite. It's the like opposing angles that use the same two lines. So my top and bottom here would be vertical, my left and right. As I squeeze the one line in, the same thing happens top and bottom, and the same thing happens left and right. Same thing other way around. If I move the line, same thing happens top, bottom, same thing happens left, right. Vertical angles are always congruent. And we have like a minute until lunch. When you get homework done, you are welcome to turn them in. This week, today's homework is the last thing due because today is Wednesday. I know it feels weird because this week has been weird. Oh, and before I forget to ask, what's your favorite kind of pie? Pumpkin? All right, a nice springtime pumpkin pie. Well, I guess pumpkin pie at Easter. Like my grandma used to do that. I think a pumpkin pie for the fall, but then again, is there really a bad time for pumpkin pie? Okay, and everyone makes their pumpkin pie slightly different, so it depends on like how much cinnamon or spice or whatever you put in. Like,